So we will look at intersection of two arrays, and the question is, given two integer arrays nums1 and nums2, return an array of their intersection. Each element in the result must appear as many times as it shows in both arrays, and you may return the result in any order. And we have an example here. So if we have nums1, which is 1, 2, 2, 1, and nums2, which is 2 and 2, what we would do is we would return 2 and 2 because those are the elements that appear both in nums1 and nums2. And here we have another example. So if we have nums1, that's 4, 9, and 5, and nums2, that's 9, 4, 9, and 8, 4, what we would do is we would return 4 and 9 because these are the elements that appear in both nums1 and nums2. And for this, we can return 4 or 9 and 4, and both would be acceptable, as it also says here that you may return the result in any order. So the order doesn't really matter. So the first thing that we would do is we would create a dictionary, and dictionary is also known as hash map in some other programming languages. And the concept is pretty similar, that we would what we would do is we would store key value pair, and then we would have an array, and this is where we would store elements that appear both in nums1 and nums2. So we will do for number in nums1, and here what we will do is we will traverse through nums1, and we will look at each element and then store it in the dictionary. And what we will do is we will see if the number already exists in the dictionary or not. So let's say that we're in the for loop and it will come across 6, and the code that we're about to write, what it will do is it will check if the number already exists in the dictionary or not. And 6 doesn't exist in the dictionary. So what we will do is we will play 6, and then we will give it a tally or a count of 1. And then it will go to 7, and then it will check if 7 already exists in the dictionary or not. And 7 doesn't exist in the dictionary. So we will add it to the dictionary and give it a count or a tally of 1. And then 3 doesn't already exist in the dictionary. We will store 3 in the dictionary, and then we will give it a tally or a count of 1. And this will be the second if statement. That would be if the number already exists in the dictionary. And 6 does already exist in the dictionary. So what we would do is we would add 1 to that tally. So this would end up becoming 2. So if we had another 6 right here, then what that would do is it would make it 3. So hope that's clear. So now what we will do is we will write those if statements, that for number in nums1, if number not in dictionary, what we will do is we will store that number in the dictionary and give it a count or a tally of 1. Otherwise, if number in dictionary, that if the number does exist in the dictionary, then what we will do is we will add 1 to the tally or the count, and we will just do +1 and increment. And now what we have is we have all the numbers stored for nums1 in this dictionary with the count or the tally, and the tally would tell us how many times that number appears. And now what we will do is we will traverse through the second nums2. So for this we will also do for number in nums2. And here what we will do is we will check if the any one of the elements from nums2 appear in the dictionary. And what we will also do is we will check for the tally or the count, and see if the count or the tally is greater than or equal to 1. Because so let's say, so now we have our dictionary here and we have nums2, So here what we will do is we will traverse through nums2 and the current element is 7. So what we will do is we will place 7 here. And then when we place 7, what we will also do is we will subtract 1 from the count or the tally. So we will do 1 minus 1, which would become 0. And then we will move to 6. And 6 does appear in the dictionary. And it has a count or a tally that's greater than or equal to 1. So what we will do is we will place 6 here. And again, what we will do is we will subtract 1 from 2. And this will become 1. And then we will move to the next element, which is 7. And then 7 is in the dictionary, but it doesn't have a count or a tally that's greater than or equal to 1 because it's 0. So we will just skip this 7 and we won't insert it in the array. And then we come across 6. The next element is 6. And 6 is in the dictionary. And the count or the tally is greater than or equal to 1. So what we will do is we will store that 6 in the dictionary, in the array, and we will subtract 1 from the tally, and this would become 0. And 8 doesn't exist in the dictionary, so we will just skip that. We won't store it in the array. And then we come across 6 again, and 6 is in the dictionary, but it doesn't have a count or a tally that's greater than 1. So that's why we won't store this in the array. So now we will take, so now we will do for number in nums2, and if number in dictionary, so we will check if the number does exist in the dictionary, and the dictionary number. So, and if the value or tally or count is greater than or equal to 1, then what we will do is we will add that number to, we will append that to our array. So we will just do array.append a number, and that will append that number to the array. And the last thing that we have to do is we have to decrement 1 from the count or the tally. So here we will do dictionary number equals dictionary number, and we will just subtract 1. And then we just return the array. So we will run this now. And this looks good, and then we will submit this. Okay, and this also looks good. So the the code that we wrote works fine, and it's able to find the elements that intersect both in nums1 and nums2. So now we will talk about the time complexity. And for time complexity, we are looking at on. The reason is because we have nums1, and we traverse through each and every element that's in nums1. So that's on. And we also have nums2, which is this right here, and we traverse through nums2 also. And we traverse through each and every element, and we only traverse through it once. So that's also on. Uh, and even though we traverse through nums1 and nums2, and it would seem like since we traverse through twice, that the time complexity would be longer, but it's still considered on. And for space complexity, we're also looking at on because we're only storing elements. So so in this case, we have nums1, the first list that we're traversing through and storing the elements of. So we are only storing as many elements as there are in nums1 in worst case scenario. So let's suppose that we have an array or a list that has elements 1, 2, 3, 4, and 5. Those are all unique values. So in worst case scenario, we would store all the elements in the dictionary.